notice how it's the other way around? You could easily in the test get that wrong. So that's 0.25, 0.35, and of course the 25 millimeters is the thickness, and that is 0.025. That is another thing that students get wrong in both the test and the assignment. They forget the zero, and therefore they end up with way too big a weight at the end of it all. The weight per metre cubed is 7850, and that's the weight of cubic metre weight of steel. That's what I want you to use in your assignment. Now that seems to vary a little bit. I've seen 7860 before. And I think in the notes it says somewhere that, but I want you to use the 7850 in the assignment, please. That times that times that times that times that equals 34.34. And the reason why I know that is because it says it over here. Okay, the last one takes a little bit of working out. So for the angle, we need to know the height, and it goes from web to web. We know the overall height of this is 533 because that's the first number here on the universal beam. That's the height. So y is going to be equal to 533. But what's the web? Well, we have to go back to, in order to find z, we have to take two lots of the web away. Take the web away from people these days and they start crying. The web is, it's either going to be 21.3 or 12.8. And when you look at a picture of a U-beam, even this one, you can see the web is quite a bit fatter than the flange. So the web is 21.3. So big Ted is what we're looking at, not little Ted. For those that were brought up in New Zealand on play school. So it's going to be 533 minus 21.3 and minus another 21.3 equals 490.4. So going back to the chart, it's 0.4904. The width is not important, but the weight per metre is given to you on this class example. As 14 kilograms per cubic per metre. So that times that times that equals 27 point something. Now how are you going to do that in your assignment if I don't give you the weight per metre? 4, 6. Course total 1, 2, 3. 1, 2, 3.
1, 1, 2, 3.
And 1. Thank you. Not often I'm wrong. Just happens to be wrong 2 times in a row.
Very quickly.
So the angle looks like this. I've said that that one's 14 per metre. The people that don't come to this class in the assignment always put 14 down, even though the angle's completely different to the 89. The ones that do come to this class go, how do we do it in the test, in the assignment? And I go, well, I've given you the angle. It's on the assignment, gave you the AutoCAD angle. And that's the square metres. How do you get the square metres of a shape like that? Join it together and list it, and it gives you the square metres. So once you've got, well, it'll actually be square millimetres. So once you've got the square millimetres, I think each angle's 100 long. It's on the, you can see it on the assignment, on the sketch. The angle goes like that, and I think it's 100. It's given to you anyway. Is it 100? I think it's 100. So it's 100 times whatever you list that as, millimetres squared. That gives you millimetres cubed. And you have to convert that to metres cubed. So I'm really playing with your millimetres and metres here to end up with a number. So that's the hard one out of all. And I think that's well within the realms of the structural. I mean, if you've done mechanics or fundamentals or whatever they call it these days, you've done structures one, I'm sure you can convert millimetres to metres squared. Millimetres cubed to metres cubed, yeah. All right? So the hardest one's the angle, easiest one's the plate, and even easier are the two, universal beams and everything. And the good news is it's also in the test. So I'm piling up some marks for you, plus the half mark people around the place. And that's it. Are there any questions on that? Definitely harder than Lucia's test, eh? Yep.
So that little shark thingy for the welding.
Yep.
Does it mean that up is left side and down is the right side?
Correct. Can't really say too much more, but yes, correct. And there's both sides.